In this question, we're given an experimental rate law. X plus y yields z, where the rate equals k concentration x times concentration y squared. Said another way, it's first order with respect to concentration of x and second order with respect to the concentration of y. It asks us what happens to the rate of the reaction if concentration of x is doubled. Well, since it's first order with respect to the concentration of x, if we double the concentration of x, which is on this side of the equation, it's going to double the rate, which is on this side of the equation. So in this case, the rate will double if the concentration of x is doubled because it's first order. So if this was 1, concentration of x was 1 molar, and you doubled it to 2 molar, the rate would be twice as fast, which makes mathematical sense because you're multiplying by just the concentration of x. So if you multiply by 2 instead of 1, the rate is twice as fast. The next question says, what happens to the reaction if the concentration of y is doubled? Well, if the concentration of y is doubled, if it goes from 1 to 2, y squared goes from 1 squared, which is 1, to 2 squared, which is 4. So the reaction is going to be 4 times as fast. Why is it 4 times as fast? Because it's squared. So it's not going to be double as fast, it's going to be 2 squared as fast. Another way of saying this is it quadruples. Note that if the concentration of y is tripled, then it's going to be 3 squared as fast, or 9 times faster, because you're squaring the concentration of y, because this reaction is second order with the concentration of y. Next question. What happens to the rate of the reaction if x is tripled and y is doubled? Well, if x is tripled, this reaction goes 3 times as fast because it's first order with respect to x. And if y is doubled, it goes 4 times as fast. And if you do both of these two things, you have to take the 3 times the 4. Why? Because it's concentration of x times the concentration of y. So if we take 3 times 4, the overall reaction goes 12 times as fast. So we need to consider what happens to each concentration and then multiply them together. Why? Because in the rate law, they're multiplied together. So that's how we figured that out. Finally, it says, what is the overall order of the reaction? In order to find the overall order of the reaction, we just find the individual orders and add them together. So, in this case, it's first order with respect to x and second order with respect to y. So again, first order with respect to x, second order with respect to y. So it's 1 plus 2, or overall, this is a third order reaction.